start. Assalamu alaikum wa rahmatullahi wa barakatuh, grade 4. Hope you are enjoying your week. And in this video, inshallah, we are going to complete the waves lesson. We are going to talk about waves interaction, but before talking about anything, let's start with the dua. اللهم لا سهل إلا ما جعلته سهلا فأنت تجعل الصعب إذا شئت سهلا يا رب العالمين. اللهم إني أسألك فهم النبيين وحب المرسلين وإلهام الملائكة المقربين. اللهم إني أسألك قلبا خاشعا ولسانا ذاكرا شاكرا إنك على كل شيء قدير. Okay, we all agree that waves transfer energy and waves move energy from one place to another. Like for example, sound energy. You can hear my sound because there is a wave that's moving my sound or transferring my sound to you. What if two of me and you are talking in the same time? What will happen to those two waves? I'm talking now, try to talk and let someone listen. He or she will not recognize what you are saying. Our waves will interfere. Sometimes when waves interact, it makes noise. Sometimes when waves interact, it makes noise. When I'm talking with, for example, I'm talking with low energy, small waves, and you're talking with low energy, but if we start talking together, we will make high energy wave. And some other times, for example, maybe in a musical concert like this, each musical instrument is producing sound energy, and this sound energy transferred through different waves. All of those waves interact together to give this harmony, to give this harmonic wave, or to give this beautiful sound. So some waves, when they interact, they make noise. Some other waves, when they interact, they make harmony. Also, light waves can interact. Can you see those spotlights? Each spotlight alone giving low energy or small amount of energy, but if those waves interact, they will give a wave with high energy. Can you see the light waves interacting together through these spotlights? Maybe we found it in theater or in cinema or whatever. In page 162, you can find two waves that like each other exactly, trough with trough and crest with crest. When those two waves interact, they will give another wave with higher energy than them both. Do you think the result has the same or different wave after combination? What happened or after they interact? If same waves interact, they will give same wave, same like them, but with higher energy, with louder sound. What if the two waves are different? Can you see those two waves? They are not different. Trough with trough, crest with crest, same wave with higher energy, with higher amplitude and higher energy. What if the two waves are opposite? What's the meaning of opposite? Opposite means trough with crest and crest with trough, opposite to each other. As I told you in class, opposite mean cancel. If the two waves are opposite to each other, they will cancel each other and give no sound. And there is an application for this fact, which is the noise cancelling headphones. Noise cancelling headphones is a kind of headphones. When you put them on, they will cancel any sound wave trying to enter your ear. Like for example, if I want to study and the place is very noisy and so many sound waves are interacting and trying to entering my ear and they are really bothering, I will put on this noise cancelling headphone and it sends the sound wave and it produces opposite wave to it, and a wave to cancel this entering wave, so I will not hear any sound. So the wave, can you see entering wave, it produces cancel wave, and opposite wave to the wave that's trying to enter my ear to cancel it. So this is the entering wave. These noise cancelling headphones sense it and produce an opposite wave, and these opposite wave cancel the wave at all, so no sound entering my ear. In page 163, we can find this question. What would happen if two opposite sound waves combine? As I told you, opposite mean cancel. The two waves will cancel each other like the noise canceling headphones. Excellent. Here in page 164, we can find a complete section. Putting it together, select the word from the word bank to make each statement correct. We have amplitude, louder, quieter, combine, cancel out. The noise cancelling headphone work when sound waves, excellent, combine. It works when sound waves combine together. The headphone cancel out the unwanted sound with small amplitude, so they cannot be heard. It cancels the unwanted sound with small amplitude, so they cannot be heard. At concert, waves can combine to form louder sound. Waves of different waves of different musical instruments combine together. Waves that came out from different musical instruments to transfer its sound, combine together to give louder sound. And even if you were in the cinema or in a theater, they place so many speakers. Those speakers give loud sound. Those loud sounds combine together and make the sound louder and louder because of the waves interaction. If you move to the lesson check at page 167, we can find question. This question is asking you to explain three points. How waves carry energy, identify the properties and parts of the wave, identify what happens when waves interact. Number one, how waves carry energy. How waves carry energy. Think about it and we will come after a while. Think about how waves carry energy. How waves carry energy. Waves carry energy when it moves. Excellent. Waves carry energy through movements. When it moves from one place to another to carry it. Like, for example, when I'm talking right now, you're hearing my voice, how the wave is moving and carrying my voice to you so you can hear it. Let's see that. So, waves carry energy through movement. It moves and carry energy from one place to another, like sound energy and like water waves and so on, that carry wind energy. Identify the properties and the parts of the wave. Waves are consist of crests, tops, base, troughs, wavelength, and amplitude. This is the crest and trough and wavelength, the distance between two successive troughs or two successive crests, and the amplitude, which is half the distance from the crest to the trough. From the crest to the trough, half this distance. This is the amplitude. Identify what happens when waves interact. If the waves are alike, crest with crest and trough with trough, it will give us high energy wave. If we're talking about sound wave, it will give us louder sound. If we're talking about light wave, it will give us brighter sound or stronger sound. About light wave, it will give us a stronger light or brighter light. Opposite wave, what if they are opposite? We said opposite mean cancel. And opposite wave mean crest with trough and trough with crest. Interact together, cancel each other, so no wave, no energy transfer. Choose the word that make each sentence correct. We have quickly, slowly, small, large, energy. If a spring is wiggled, space. The amplitude of the wave that form is space. This is because the amount of space of the wave is small. So the wave is small. So let's return back. If a spring is wiggled, the wave is small. So if the wave is wiggled slowly or quickly or slowly, excellent. The amplitude of the wave that form is small. This is because the amount of energy of the wave is small. Super. Write high or low on each line to correctly describe the amplitude of each sound. We all know that amplitude affects the loudness of the sound. If the sound is loud, the amplitude is high. If the sound is soft or quiet, the amplitude is low. What about this trumpet? Poo, 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 poo. High sound, loud sound is high amplitude. Meow, cat meowing. Meow, meow. La quiet sound or soft sound is low amplitude. Sparrow tweet or a bird tweet, low amplitude as the sound is quiet or soft. Fireworks, we hear it in the sky, so it's loud with high amplitude. In the second column of the table, write long or short correctly to describe the wavelength of the wave. Like for example, the surfing wave, the sea surfing wave. Is its wavelength long or short? Long, excellent. What about the seismic wave? The seismic wave is the earthquake wave. When there's an earthquake, there's energy, and those energy transfers through wave. Is the wavelength of this energy long or short? Excellent, long. What about the tuba? Tuba is a musical instrument like this trumpet. Poo, 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 poo. So it's high pitch or low pitch? It's low pitch, as it's very rough sound. Poo, poo. And we said the lower the pitch, the smaller the number of waves. When the number of waves is small like this, a little waves, so we have longer wavelengths. When the pitch is high, we have more number of waves and shorter wavelengths. Okay, again, when the pitch is high pitch, we have so many waves and shorter wavelengths. When the pitch is low, very rough sound, low sound, like the tuba instrument, poo, 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 low pitch sound, little number of waves, longer wavelength. But what about the duck whistling? High pitch sound, more number of waves, shorter wavelength. Okay, so the surfing wave has long wavelength, seismic waves, long wavelength, tuba, woo, 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 woo. Low pitch sound, small number of waves, longer wavelength. Dog whistling, high pitch, more number of waves, a lot of waves, shorter wavelength, so short. It seems like I showed the answer of the next question. Which of the following are example of waves interaction? A full orchestra playing song. Yes, a full orchestra playing the song is an example of waves interaction. When a lot of musical instruments work together, giving sound energy, so many waves interact together to give the harmony, this beautiful sound. Moving the spring back and forth. Where is the interaction here in moving the spring back and forth? Having two spotlights on a performer. I show you those the spotlights. Those two spotlights. Those spotlights. A lot of spotlights together. Doesn't this show light waves interacting together? Interaction. Yes, they show actually. Okay. Watching a movie in a surrounding sound. In surround sound, a lot of sounds around you while you're watching a movie. So waves interaction. Tuning a piano to the correct note. Tuning a piano to the correct note. You're tuning the piano, playing those fingers of the piano together to make a note. So waves interaction. Wearing a noise cancelling headphone on an airplane. Yes, opposite wave, cancel wave. These noise cancelling headphones produce an opposite wave to the waves that's entering your ear to cancel it. Choose the word or phrase that make each statement correct. Space or a device that space out unwanted sound. Noise cancelling headphone, excellent. Noise cancelling headphone, what it do to the unwanted sound? It cancels it out. Another device is the theater spotlight that also show how waves can interact. The theater spotlights show how waves can interact. When only one of these objects is used, waves do not combine. In the lesson roundup, which of these evidence that ocean waves have energy? Select all the correct answers. They can combine or cancel each other. When two waves hit each other, didn't they cancel each other? And doesn't that an evidence of energy in the wave? So this is an evidence. So when they combine, they cancel each other. They need a medium in which to move. This is not the evidence that wave has energy. They make things wet. Actually, if I put a cup of water over you, it will make you wet without proving any kind of energy. Or without proving that the wave, it's not a wave and it makes you wet. So if you enter the sea without any wave, you will be wet. So where is the evidence of energy in the ocean wave here? They crash when they hit the shore. Isn't this an evidence? Yes, because once it hit the shore, it crashed because it released its energy. Which of these statements are true? Select all of the correct answers. All waves move up and down. Of course, now we have side-to-side waves. Some waves don't need medium in which to travel. Some waves don't need medium in which to travel. Yes, like the light wave. Light wave doesn't need medium to travel. You are seeing the light of the sun. Light wave doesn't need medium to travel. We are seeing the light of the sun, although the sun is in the space. And in space, there is no medium, there is no air, and it can travel to us, the light waves. So some waves don't need a medium in which to travel, yes, like the light waves that travel in the space and came here to our Earth. Some waves, lake, trough, and crests. How it could be a wave in this way? All waves move back and forth. Of course not. We have up and down movement. Some waves transfer energy and some transfer matter. All waves transfer energy. Let's label these waves. We have A, crest, B, trough, C, wavelength, D, amplitude. Crest, where is the crest? It's the top. So a crest is the top. That's why we place the letter A, the letter of the crest here. Where is the trough? The bottom of the top. Excellent. What about C, the wavelength? Exactly, the distance between two troughs or two crests successfully. What about the amplitude? D. Excellent. It's half the distance from the crest to the trough. Half this distance. What else have you learned about waves in this lesson? What else did we learn about waves? We know that it carries energy, not matter. It interacts. It moves side to side or up and down. Okay. If you know more things about waves, of course, we know a lot of things. We have different kinds of waves, waves that can carry so many kinds of energy. You can write your answers. It's an open question about what you learned about waves in this lesson. Thank you, grade 4. Hope you understand every point in the lesson. If you have any question, don't hesitate to ask us or send us messages on Edmodo. Thank you so much. Assalamu alaikum wa rahmatullahi wa barakatuh.